Welcome everyone in this first episode of a series in which we will be recreating a Twitter-like backend using the amazing Neo4j GraphQL framework. In the description you will find a repository which is associated to the project and where I'll be pushing all my commits. And you'll also find a link to a Medium article in which I explain the boilerplate, which I won't present in this video because it's boring. So, without further ado, let's get started. So the first thing we're going to be doing is design the data structure of the database. So Neo4j is what's called a graph database, unlike, for example, MongoDB, which is NoSQL, or Postgres, which is a classic SQL database. In Neo4j, there are no rows and tables, but everything is simply either a node or a relationship. So a node is something that represents any object. And a node will have a type. So for example, in our case, one of the main types is going to be the user. And this node will have properties. So for example, email, the name, when it was created, and so on. And then we have relationships. So for example, in our case, one of the actions that a user can do is follow someone else. So in that case, we're going to be creating this, designing this schema where a user can say follows another user. Okay, what else can a user do? Well, a user can create a post. So let's just put that. Oh, that sometimes happens. Okay, can create a post. Great. We can say offered. All right, but a post, as you may know from Twitter, a reply to a tweet is also a tweet. So we can also say that a post can be a reply to another post. So we can have an initial post and then a reply from it. So here we can call the relationship replies to. Great. And what are we missing? A post can have tags connected, for the record. And finally, the last thing that we're missing is that a user can like a post. So let's just say likes, and here we just say a post. So this is basically the schema of what the data structure that we're going to be creating with Neo4j GraphQL. Okay, so now I'm going to be designing it, writing the code, and I'll be right back to explain it. Okay, so we're back and we've designed the structure, so I'm going to be explaining it bit by bit. So what does a user have? A user has an email. And the email we define as a string, and this exclamation mark means that it's required, it's not nullable. And we also add this little directive. This is a directive built in the library. And what it does is inform Neo4j, the database Neo4j, that it must add a unique constraint on the email, meaning that there cannot be two users with the same email. Then we have a name, which is also a string and which is also required, but this one, of course, doesn't need to be unique. Finally, we have this created at and updated at, which are both date times, which are both required. Now this directive timestamp, what it does is that it will automatically take the timestamp at the point of creation. So in this case, with this operation create, it means that when we create a user object, it will automatically fill the created at with the current timestamp, and only at the operation create. Whereas for the updated at, it will fill it at the create time, and then each time there's an update of the object, it will also update it. Okay, now we move to the post, and we start with the post ID. It's of type ID, which means a UUID. It has an exclamation mark, so it's required. And this ID directive fills the post ID with generated unique UUID v4 when the post object is created. We also have this content with a string. So the content is just going to be basically the post, and it's required obviously, and then we also have created that and updated that. Finally, we go to the tag. Here we can see the slug, and we also had a unique constraint here. So this unique constraint is going to be very useful to automatically connect posts with which have the same tag. So what do I mean by this? Suppose that this tag is a Python, okay? And suppose that this post also wants to add the tag Python. So without the unique constraint, what would happen is that we would end up with two different tag objects with the same value, with the same slug value of Python. This is not what we want. Instead, we want to create the connection. So we want to have this connection. To be able to do that, we need to put the unique constraint on the tag. All right, so right now we've only created the objects, but we haven't actually created the relationships between the objects. So let's go ahead and do that. Okay, so I've added all the relationships. Now let me explain them a second. So let's start with follows. As we said, a user can follow one or more other users. So we have user as a list, and we also have this required. The exclamation marks are required by the library, otherwise it will not work. We can try after to remove them. That's just something to know. That doesn't mean that the list cannot be empty. It simply cannot be null. And we use this directive relationship to say what is this? Well, it's a relationship, and what's the name of the relationship? It's follows, and what's the direction? It's out. So we have to add the direction because Neo4j requires relationships to be directed. So it must be an arrow. It can't just be a connection. And therefore, it's just you have to decide what's the direction that makes sense. There isn't a rule for that. It's just which one makes sense. Likes is very similar. Instead of being a user, it's a post, but it's always an array because a user can like many posts. And same with posts. So this is the post offered by the user, and it's again a list of posts. For the post, we added the reply. So the important thing here is that this is not a list, first of all, because a post can only reply to another post. So it's not a list, and it's also not required because a post can not reply to anything. And now we can launch the Docker Compose. So we just do Docker Compose up, and this is going to launch the backend as well as the Neo4j database. Okay, so once you see both the Neo4j started as well as this GraphQL server ready, that means we're good to go. Let's open the link, and you should end up on this page. Then simply click query your server, and let's wait a second. So the first thing that we notice is that the schema doesn't actually load, which is a bit of a problem. This is because the URL provided by the log is from inside the Docker. So instead we have to use localhost and not 0000. And as soon as we do this, we see everything appears. So we immediately see that we have all these generated queries that we can do. So we could get all the fields from different posts. We have the work conditions that we can add for every field. We have the options that we can add. So everything is automatically generated simply from writing this. And same with the mutations. So we can create posts, create users, delete, update, everything. Okay, so let's just go ahead and create two users that we're going to be using for the test. So let's just check, run the query, and we can see that we have created these two users. Okay, let's log into our Neo4j website. So you can also open this address, localhost :7474/browser, and this is how we connect to the database. Username and password is empty, so just to connect. Wait a second. Okay, now we can start. And the first thing that we can do, so I'm not gonna explain exactly what these queries mean. That would be a video of its own. It's this query language called Cypher, but right now we only need very basic queries such as select all, basically. And we can see that we indeed have two users, which have the created that and updated that populated, and with the email and name values populated. So up to now, everything is good. So let's go back and now let's try to create some posts. Okay. And this should be good. So let's go and create the post. Perfect. Okay. And now let's go back on Neo4j and oh, right. It's missing a connection. We didn't have to say who the offer was, even though in theory it would be required. Why is that? It's because we didn't add it in the schema. As you can see, we only create the connection from user to post, but not the connection from post to user. Instead, now we have to also add the offer connection and say that this is a user and that it must be provided. And then add relationship to type. The same type, it has to be the same type as we said, as we put here, otherwise it's simply going to think that it's another relationship, another connection. And this time the direction is in, right? Because it was going out from the user and it's going in the post. Okay, and now if we just save this, it's going to automatically relaunch the updated server. And if we go back and we try to recreate the same post, we'll get an error. Post.offer is required, of course. So let's first delete what we currently have, which is extra. So it's the post detach delete p, and we're also going to be running the same for the tag. So we were just deleting all the posts and all the tags. Okay. Let's go back, check. Indeed, we only have the two users, and now we can add the offer. So that would be offer, and we say, never remember exactly how these functions go. So let me just actually, there it is. And we want it to be a connect. Connect where? User where? Email, and let's put the value. Okay. user1@gmail.com. Perfect, this should work. Amazing. And if we go back now, there it is. We see the user1 offered this post, which has this tag, and everything's good, everything's perfect. So this concludes the first part of the series. Let me know if you enjoyed it, and we'll be back later on this week with the next part. Thank you for watching and have a good week.